everyone, and welcome to day 2, the definition of a derivative. Just to review, average rate of change, if we have the points x0, is that not working? And f of x0, and x1, and f of x1. So those are our 2 points. How do you find the average rate of change? Well, change in y, f of x1 minus f of x0 divided by x1 minus x0. That's our average rate of change, the slope between 2 points. Instantaneous rate of change, where that distance between those 2 points are almost zero, that's the instantaneous aspect of it, is a limit as x1 approaches x0 of f of x1 minus f of x0 over x1 minus x0. And we went over that last set of notes where we found the actual instantaneous rate of change for a specific one and a generic one. So the definition of a derivative, which you guys saw last year, is where the f of x plus h minus f of x all over h, the limit of that as h approaches 0. Well, let's look at what this is saying. This is saying that the y value right here, where the distance is basically 0, minus the actual point, divided by that distance being 0. Well, it can't be 0, but if we look at this, this is really saying x plus h minus x. If we look at what change in y over change in x, this is our x value, x plus h. This is our other x value, x. Those x's cancel and we're left with just h. That's why it's divided by h. So as a result, the blank equals the slope of the tangent line. The derivative equals the slope of the tangent line. And so just some different ways we can write the derivative. F prime of x, dy over dx, sometimes it's just d over dx. We can talk about that being at a certain x value right there. We have d, sometimes it can be like this. That's not one we see. Just so you guys know, this is Leibniz notation. He was the mathematician that came up with this. What is this really saying? This is a change in y over change in x, delta y over delta x. It's one way they can describe it, but at the instantaneous rate of change. Sometimes the derivative with respect to x of f of x there, and I think that's probably the only notation you guys need to know. So let's use the definition. Remember that the definition is a limit as x approaches, or as h approaches 0, of f of x plus h minus f of x all over h. Remember, this is an h right here. So we've got f of x plus h equals x plus h squared. All I did was plug in x plus h where I saw the x. We know that's x squared plus 2xh plus h squared. F of x, which we know is x squared. So all I'm going to do is now plug. So we've got the limit as h approaches 0 of f of x plus h, which is this, minus, so that's all of f of x plus h, minus f of x, which is x squared. Now what I like to do is put that in parentheses just so I know what I'm doing, all over h. If you are going to do this correctly, every time, whatever f of x is will cancel. Please know that. Anytime you have this formula, you will always get f of x to cancel with what f of x plus h is. When that happens, you can then always take out an h, cancel it with this h, and plug in 0 and move on. So we've got the limit as h approaches 0. These x squareds are going to cancel. 2xh, where did I do that? 2xh plus h squared all over h. Limit as h approaches 0 of, we can take an h out here, 2x plus h, just so you know where that's going. Those h's are going to cancel. You're left with 2x plus h. When we get down to this point right here, we get plug in 0 for h, and you're left with 2x. So what do we know? That the derivative equals 2x. So just as a recap, found f of x plus h, you found f of x, you subtracted them. When you do it correctly, always get them to cancel. You can then always pull an h out. Those h's will cancel. That is an awful h. There you go. You got 2x plus h. Plug in 0 for h, as we now no longer have a fraction, and you get your derivative. On to the second example. We're going to go 3 parentheses x plus h all squared plus 7 parentheses x plus h. You can do that out. I'll let you guys know that's 3x squared plus, you're going to get 2xh here, so that's 6xh, plus 3x squared, 3h squared, excuse me, plus 7x plus 7h. Now, I do understand that this is going to get long, tedious. Just remember, it's the only time you have to do it is this unit. So, f prime of x equals all of that minus that. All of f of x plus h. Minus, in parentheses, 3x squared plus 7x. All divided by 3x squared. Oops, sorry. Other things here. All divided by h. Can't forget that limit. So we're going to get limit as h approaches 0. And again, remember that these can always cancel. And so what are we left with? Well, we're left with 6xh plus 3h squared plus 7h all divided by h. Notice what I said, that all of them will always have an h, so I'm going to take an h out. 6x plus 3h plus 7. When we do that, we know that those h's can cancel, and so we're left with the limit as h approaches 0 of just 6x plus 3h plus 7. And we know that that's just going to result in 6x plus 7 to be our derivative. Why? Because 3 times 0 is 0. Those are gone when we plugged in h. Oh boy, now we get into a square root one. We all get worried. Take a moment, at least get the fraction written out, and then unpause it. So you notice here that we have a fraction that has square roots. And what do we know from before? Why did we do all those limits? Well, we did all the limits because we need to multiply by its conjugate. Yay! Why are we doing this? Because we really have no other way to figure out this limit. So when we do that, remember it's x plus h minus x all over h parentheses what is left over here. And when we do that, these x's cancel each other out. You're left with h over h. And so we are going to be just left with 1 over square root of x plus h plus square root of x, limit as h approaches 0. Well, when I get to this point, I'm just going to plug in 0. 1 over square root of x plus 0 plus square root of x. And I'm going to get 1 over 2 square roots of x. Square root of x plus square root of x, 1 over 2 square roots of x. And we're done. That's honestly all you had to do. So do not try to make that more difficult. You saw square roots, multiply by its conjugate, do the algebra out, and realize that these wonderful people in the hallway, these x's you can add together, square root of x, you get 2 square roots of x. Oh, now we get to this one. Again, try it out, see what you get, and then come back. Well, guys, hopefully you realize that this was a problem that looked exactly like one on your test that you guys took. So we have the limit as h approaches 0 of f of x plus h minus f of x. We need to find common denominators. You could have put that over 1 if you wanted to. I showed out the common denominators here, and so when you have common denominators in a complex fraction, you can cancel them out. So you're going to be left with x minus x plus h all over h parentheses x times x plus h. Well, when we do this, you distribute the negative, and so we are going to get negative h over h parentheses x plus h. Those h's will cancel. Plug in 0. So those h's will cancel. You get negative 1 on top. Plug in 0 here. You get x times x, and you get negative 1 over x squared. There's your derivative. Okay, on to the last one. All this is stating, and I'm not going to go over this because we have a cube. If you don't want to go over it, that's fine. You're going to get f prime of x to equal 6x squared minus 2x minus 3. What this is stating is that you're going to plug in 1 at that moment. So 6 times 1 squared minus 2 times 1 minus 3. 6 minus 2 minus 3, we're going to get 1. So all that's saying is that's the instantaneous rate of change at the value of x equals 1. This is the slope at x equals 1. It is not the generic slope like we had back here to just be negative 1 over x squared. That's generic. That's at any x value. This is asking you to find the derivative and then plug in 1. I'm not going to make you guys do a cubed out here at all. Joke of the day, more like the line of the day, math is like love. It's a simple idea, but it can get complicated.